So the first question we will cover today is what is linked list. So a linked list is a linear data structure in which elements are not stored at contiguous memory location. So that's all you need to remember, that linked list is a linear data structure, and in linked list elements are not stored at contiguous memory allocation, but the elements are linked in a way in using pointer shown below. So here, as you can see, these A, B, C, D, these are elements of a linked list. These are stored in the linked list, and those are stored using linear data structure and pointers. So where is the pointer here? You see, after A, there is an arrow that is pointing to B. After B, there's an arrow that is pointing to C. So if I actually draw here, you see, this is our first data, this is our second data, this is our third data, and this is our fourth data. So if I actually highlight, so from A is the first, B is the second, C is the third, and D is the fourth. And why this is called linked list? Because you see, after A, there is a link or there's an arrow between B, A and B. So they are actually connected by a list, or I can say they're connected using an arrow, or they're connected by using a pointer. However you put it, it doesn't matter. The main thing is that in a linked list, you have two parts. You have the data that is here, as you see. You have the next. What is next? It's a pointer that points to the next memory allocation. Now, first, this is a linear data structure. As you can see, data is stored linearly, okay, one after another. Secondly, there are two parts of the linked list. First part is called data, second part is called pointer. So what is pointer? It will point to the next memory address, that is B, C, D. Now, the two things were need to be clear, that when I say pointing to the next memory or the next data, how it is being done and why this type of procedure is better than the array. So let me first make sure that we are clear about the definition, then we'll go to the working procedure. So a linked list is a linear data structure. This is point number one. And in point number two, the elements are not stored at contiguous memory allocation. The elements are linked using a pointer to the next. So if I write the definition here, okay. So let's assume I'm trying to write it. So same as the first line, linked list is a linear data structure, okay. And then this is the first line, and the memories are not contiguous, second point, and connected using a pointer between them. So these are the 3 points you have to be very clear. And if I ask you this definition, whatever definition you give, it must contain these 3 points. I hope I'm clear. Now the next part, that we understand what is linked list, okay, but why linked list is actually better than array. So we will then go to our next share. Let me share the screen. So this is our next topic, array versus linked list. So this is an example. You see, if I store a data in an array, we use contiguous memory allocation. So first thing, that if you are, let's assume I am storing these values x1, x2, x3, x4, x5, x6 in an array. Okay, suddenly there is a new value that I want to store, that is let's assume that is y. So in an array, data are stored one after another. Okay, so x1, x2, x3, they are actually contiguous, that means one after another. Now suddenly if you want to insert y, what you have to do, you have to first move x2, you have to move x3, x4, x5, and x6. So all of this, okay, all of this data has to be moved in this direction in one space. So this is one problem, that to store one simple data, I had no option but to remove, or I had to shift all the memory allocations. So this is one problem. It's like this, that if, so let's assume that five friends are sitting next to each other. Okay, So whenever a new friend is trying to sit, what you have to do, you have to move all the friends to one space to the right, or shift one space to the this direction. So this is one problem with array. But whenever we are storing the same information using linked list, okay, you see x1, x2, x3, x4. So these are elements of linked list. And if you want to insert a new element y, all you have to do is just create a link. The data will be automatically stored. You don't have to do anything with x2. You don't have to change x3. You don't have to change x4. So these data were stored in the exact memory location. Now I will go for another demonstration. So let's take a wide screen. So let's assume that this is my computer's memory. Okay, so this is my hard disk. So we can store a lot of information in the hard disk. Okay, this is my hard disk, and we have like small boxes like this where we can store data, we can manipulate data, and so on. So we have a lot of spaces like this, okay, in our hard disk. And this all of them are small rooms where we can store, let's assume, integer. That means we can store one integer in each of these blocks, and it goes on like this. Okay, the first problem we faced with array, okay, I will list them down one by one. That, oh sorry, let's assume this is here and this is here. So whenever we are working with array, okay, we're actually very happy because array was, you could actually easily declare 100, 200, 2000 variables in one go. Okay, so at first people are very happy with array. Okay, but the problem started, number one, okay, the problem started is array is static. Static means that in normal array, if you want to store 500 data, you have to initially declare array 500 or more. So that means if you need to store 500 data, you first need to declare an array of size 500. So that should not be a problem, right? Because I am the programmer, I should know how much memory I need. Okay, but the problem was, what if you are not using all the memory? So let's assume you have written a program that can store 500 students information. So every time you run the program, it stores 500 students information. But problem is, initially, whenever your program is running, it is only storing 2 or 3 or 4 students information. All of the rest 498 spots are left vacant, but their memory is allocated. This was your problem number one, that it was static, you couldn't change it. Even though out of 500, if you're using only 2 or 3 or 4, you had to declare a memory of 500. Number two, if, okay, if somehow you had to change the array, that means somehow you saw that your program was for 500 students, but now you need more, 600. So there is no way you could change it unless you again open your code and you change the size of the array to 500 to 600. So that was another problem, that if the size was small, that if I go for Bangla, that if like if you declared a memory, but the required or the usable memory is less than that, okay, in that case, you still needed to declare 500 space. So just think like this, that you actually arranged a party for your friends, and you have invited 500 friends. But out of those 500 friends, okay, you are not sure how many of the friends will come. So what you did, okay, in advance, you have actually booked 500 rooms. So it doesn't matter whether one friend come or 5 friend comes or 500 friend come, you have to pay the rent for 500 rooms. So this is an array. Even though you have only 2 friends, you are paying the rent for 500 rooms. Another problem was that you had 500 rooms, but now suddenly some of your friends actually came with their relatives as well. So now you need more room. So what you have to do, you have to again go back to program, and you have to book a new room. You have to book the new hotel. You have to change the hotel. So why all go through all this trouble? Okay, so linked list is actually solve these problems. The first thing linked list does, instead of booking 500 rooms, it books on basis. That means if 3 friends come, it books 3 room. If 4 friends come, it books 4 room. If 5 comes, it books 5 room. So you don't have to pay rent for the 500 rooms. Okay, so this is one advantage. Second one was, if by chance more than 500 friends come, so in that case you can just book 500 rooms from anywhere. So this was the first advantage of linked list. Secondly, okay, another thing that is the most crucial part, the contiguous part. So let me show this, what does contiguous means. So let's assume that you have the friends you have, okay, you want them to stay in a contiguous room. Contiguous means like, this is suppose the first floor, and if you want all of your friends to stay in all these rooms, okay. So like let's assume 1 2 3 4 5 6 7 8 9. Okay, I have 9 rows here. So let's assume you have 8 friends. So what you want to do, you want to keep them in a contiguous room. That means side by side room. Okay, so all of your 8 friends will be in this place. Okay, so whenever we need contiguous memory allocation, we need an array. Okay, now if what happens that if you have 12 friends, okay, but in this one I can only keep 9 friends. So what will happen that here, as you can see from my computer's memory, at most 1 2 3 1 2 3 4 5 6 7 8 9, at most 9 people can stay in one floor. Okay, because if you need to stay more friends, you need to go to another floor, because in this floor there is only 9 room. But in case of memory or contiguous memory allocation, if you want to declare an array of size 10, your program will say that the size invalid. Okay. Again, let me repeat the point. In contiguous memory allocation, okay, if you want to declare an array of size 10, your program will say computer is out of memory or memory issue. So, but we can see that all of these rooms are empty, but still, if I want to declare a room of 10, it's saying that this is out of memory. So why this problem happens? Because you see in this one, in your computer memory, at most you can declare 9 room side by side. So in an array, we have contiguous memory allocation. That means the memories have to be side by side. So this is also a huge problem. Okay, so these are the two basic problems. One is arrays is static, you have to fix first, and you have to always reserve those memories, just like paying the rent for 500 rooms. And second problem is that even though your computer has a lot of space, okay, in this case you can only declare array of size 9. You cannot declare array of size 10 or 12 or 11. At most array of size 9. Why array of size 9? Because there are 9 columns side by side, or 9 adjacent or contiguous memory locations. But in case of linked list, how it solves it? Linked list, what it does, it actually, instead of booking all the rooms, okay, it randomly books the room. So suppose your first friend came, he will give in this room. So this room is for our first friend. Okay, so let's assume this is for the first friend. He is in this room. Second friend came, he will be in this room. Oh, sorry, this is actually here. He will be in this room. Third friend came, he will be in this room. In this way, what will happen, even if you have 20 friends, 25 friends, okay, all of them will have spaces in somewhere. Okay, all of them will be stored in somewhere. They don't have to be contiguous. Okay, now there is another part I said, that in a linked list there are two parts. One is the data, that which friend is staying in which room, and second one is their connection between them or link between them. So what will happen, that if the friend 1 stays here, okay, there will be a link or connection from friend 1 to friend 2. If friend 2 stays here, there will be connection from friend 2 to friend 3. Now normally this connection is not like this. Okay, what we do, okay, we actually store the address of each person. So instead of drawing arrows like this, what we do, in the room number of first person, okay, let's assume this is the room number, let's give a number here, so let's assume this is the fourth floor, this is the 5th floor, this is the 3rd floor. Okay, so the first friend is living in 4th floor, room number, first room. Second friend living in 5th floor, room number 4. So what will happen, this person, person number 1, it will store two things. Okay, his room number and next person's room number. So this is all about the basic of linked list. So every person will store his own data and the next person's data. Okay, so let's go back to our slide. So I hope everyone understood this two example. Now, if I actually go back to again so let's see what are the differences between array and linked list. Okay, so there is a so this is the visual representation. Okay, that arrays are actually sequential, contiguous, but linked list can be unsequential or uncontiguous. Now, the first difference is that a data structure consisting of collection of elements each identified by the array index. So in the array, we have array index, array 0, array 1, array 2, array 3, and so on. A linear collection of data elements with order is not given by their location in the memory. So basically there is no order. Okay, we just know where the linked list starts and we know that what is the next. So basically every node knows the next location. Okay, then next one, it support random access. So the programmer can directly access an element from using the array index. So that means you can directly access array 5, array 6, array 7, array 8. Okay, but in case of linked list, you cannot directly access array, first, second, or third. You have to always start from the first and then you have to go to the second and third. I will explain these reasons in the next class why this happens. So these are actually some of the advantages and disadvantages at the same time. Number 3, elements are stored in contiguous memory location that we discussed previously. Elements can be stored anywhere in their memory. Okay, so this is one point that we have discussed, and this is another point I want to focus. Okay, each data structure collection of elements by identified by array index, and here we identify them by location in the memory. Then we can support random access. It doesn't support random access. It supports sequential access. That means you will first start with first friend and then you will ask the first friend, hey, where is the second guy? Then you will go to the room number of second guy and you will ask the second man, where is the third guy? So in this way you will actually go one by one. Next, programmer has to specify the size of the array at the time of the declaring the array. So this is what we discussed previously. There is no need for specifying the size. The linked list, you don't have to specify the size. As your friends come, you can actually give them the room. You don't have to book room previously, okay? Memory allocation happens at compile time. So this is actually, you don't have to understand this right now because you're not about compile time, runtime, but this is actually one feature. And elements are independent of each other. That means array 1, array 2, they are directly can be accessed and processed by program, but in linked list, each element is actually connected with the next element. So basically first friend knows about the second friend, but doesn't know about the third friend. Second friend knows about the third friend, but doesn't know about the fourth friend. And this is where it goes on. So here is an example of linked list. Okay, as you can see, linked list here, whenever we are drawing a linked list, we're always using this type of box. And in that box, we're actually dividing the box into two parts. For the first part, we are using it for data. Okay, that means if I want to store a number in linked list, the data is the number. If I want to store, what should I say? If I want to store a string into the linked list, the string will be the data. Your name will be the data. And this part, this is called pointer. So what is the task of the pointer? As I said, the first friend will know the room number of second friend. The second friend will know the room number of third friend, and so on. So pointer actually points to the next memory allocation or the next friend. So these are the two parts of linked list, and this two part combinedly called a node. So this is the new name that we will be learning, that what is node, okay, how to declare node, okay, how to process node. So the term node will be actually very common in this. So in short, in array we have these variables serially one by one, and in linked list we have this node one after another. So this is all about the basic definition and differences of the linked list. Now we will see two more differences. Let's see here. They have discussed in details the accessing the elements, memory location, size. The array size is fixed, but the linked list size can be increased or decreased as needed. Okay, so this is all for the definition and the differences between linked list. Now I will take a 5-minute break